Dear students, in today's lecture, we will learn structure and union. The content of today's lecture is introduction of structure, introduction of union, bit fields in structure and union, selection operators in structure and union, different ways to access members of structure. Let us start with the first topic, that is introduction of structure. Basically, we have implemented so many programs in C language, but they all have a limitation that the variables declared in such C programs can store only one value at a time. It may be required that we would like to store multiple attributes of a single object in a C program. Such kind of cases can be resolved with the help of structure. So, with the help of structure, we can pack the data of different types together. We cannot store multiple types of data in a single primitive variables. Structure is a mechanism for packing the data of different types. It's convenient tool for handling a group of logically related data items. For example, if I would like to store the detail of a student, at that time a student may have enrollment number, name, address, age, branch, contact number. For storing the detail of 50 to 60 students, we require large amount of variables. And if we are using large amount of variables, then it is quite difficult for us to manage and remember the name of such variables related to a particular student. So, the concept of data structure can be used to resolve such kind of issues. It helps us to organize complex data in more meaningful way. Here, let us see the definition of a structure. Structure can be defined using struct keyword. For example, over here I have displayed one structure called student, which is having four members, that is integer enrollment number, character name, character address, and integer age. In the structure definition, you can see I have included a string also. You need to remember over here, structure always ends with a semicolon. Declaration of structure variable. For the structure defined earlier, we can declare variables in the following way. Either we can write in our main method the following statement: struct student st1, st2, st3, or else we can declare a structure variable at the end of structure definition. Members of structure are not variables. They do not occupy memory until they are associated with structure variables like st1. At the time of compilation, a separate memory space will be reserved for each structure variable. And if we are declaring multiple structure variable, then the member of such variables, or you can say the member of such structure variables, are having separate memory space for each other. We can also combine structure definition, a variable declaration together in the following way: struct student integer ER number, character name, character address, integer age, st1, st2, st3. Over here in this definition, I have declared three structure variable of type student. Static assignment to members. We can assign values in two different ways to structure members of earlier defined structure. Number one, either I can initialize the structure members like struct student st1 is equals to the corresponding values of each structure member. While creating a structure variable like this, we need to take care of the sequence of members, structure members defined in the body of structure. Over here, I have created a structure pointer to which holds the address of structure variable st1. The same thing I can do in another way, that is struct student integer enrollment number character array name of 20 characters, character array address of 50 characters, integer age st1 equals to the values I need to write down in the curly bracket, and the members who are of string type, they needs to be enclosed within the double inverted comma. I have declared st1 st2 as the structure variables, and pointer sptr is equals to ampersand st1 as structure pointer. In these two approaches, we need to follow the sequence of members. Members cannot be initialized in structure template. We cannot assign values to structure member while defining the structure. Of course, partial initialization is allowed, but uninitialized elements should be at the end. It means the partial initialization can be defined, for example, st1 equals to 2. The rest of the three parameters can be assigned using the dot operator or an arrow operator in structure pointer. Uninitialized integer or float will be assigned to 0, and character will be assigned to null character. Copying and comparing structure variables. When two variables of same structure type are to be copied, then it is possible in the way we are doing with the ordinary variables. That is, for example, st1 and st2 are two structure variables of structure student, let's say, and I have assigned the values to the members of st1 variable. Then I can copy the version of st1 structure variable to st2 structure variable by writing st2 is equals to st1, so that all the values assigned to the members of st1 will be assigned to the member of st2. In other way, I can say I have created a duplicate version of st1. They both are having the separate memory space. Comparison of same structure cannot be performed like ordinary variable comparison, but we need to compare each members of it individually. If I would like to compare the members of st1 and st2, then I cannot write st1 double equals to st2. Instead of that, I need to write down st1 dot name or st1 dot age double equals to st2 dot age. strcmp st1 dot name comma st2 dot name. I can compare the different variables of same structure in this way. We can create an array of structure in the same way we are creating an array of primitive data, right? And they all the elements of array holds the separate memory location for each elements and members of it. For example, if I would like to create an array of integer, I will write integer a square bracket 10. It creates an array of 10 elements. Similarly, we can create an array of structure by writing struct student st of 10, which creates 10 separate variables being identified by its index value. The total size of structure variable is the addition of size of all the members of structure. For example, if my structure contains one integer and one character variable as a member of it, then the size of my structure will be 2 for integer plus 1 for character is equals to 3 bytes. Next topic is introduction of union. Union is little bit similar to a structure, but the only difference is that in a union we can store only one value at a time, though we are having different members as a part of union. Sometimes we want to store different types of data in single name as per the requirement. Then union is a mechanism to store different types of data in a variable, but it can store only one type of data at a time. Defining a union. Union can be defined using a union keyword, that is union, name of the union identifier, integer m, float x, character c, and semicolon. Similar to a structure, union also ends with a semicolon. The compiler allocates the storage that is large enough to hold the largest member type in union. For example, for the union specified above or defined above, I can say the size of union is the maximum variable data type, that is the float is having the maximum size, so the size of union will become 4. All the three members of union shares the common memory space. When a different member is assigned a new value, the new value overrides the previous member's value. As I explained earlier, union can store only one value at a time. So from these three variables, if we store a value to a single member, then whenever we try to store value to another variable, the first variable's value will get vanished. Declaration of union variable. For the union defined earlier, we can declare variables in the same way as we have declared in structure, that is a union, union name, variable name, semicolon. Static assignment to members of union. We can assign the values to union members same as we are assigning to structure member, but we need to always remember only one variable can be assigned at the same time. Union may be initialized when the variable is declared, but it can be initialized only with a value of same type as the first member. As you can see in the definition, if I would like to initialize the variable of union item, then I can only initialize it by using integer m. So it will be like union item x is equals to in curly bracket 10. That is the only initialization I can perform because the integer is the first member in the union definition. Next topic is bit fields in structure and union. It is an important concept so far as the memory consumption is concerned. For example, if we are declaring an integer member in a function in a structure definition, at that time it may be possible that our requirement is to store only 1 to 100 numbers, but as we know, an integer can store approximately 65,000 plus value. The maximum value an integer variable can store, that is 65,000 and something, right? So if in our C program, if there is a requirement of the minimum value 0 to 100, it says that the rest of the memory will get wasted. As you know, the size of integer variable is 2 bytes, and those 2 bytes can be converted into 16 bits. To store the maximum value 100 in such integer variables, we require only 7 bits. So rest of the 9 bits will be wasted out. So in such cases, we can use this bit fields in structure and union. There are occasions where data items require much less space than a variable consumes. C allows us to use small bit fields to hold data items and thereby to pack several data items in a word of memory. It allows direct manipulation of string of pre-selected bits as if it represented in integral quantity. It can be efficiently used with integer data member. It is a set of adjacent bits whose size can be 1 to 16 bits for integer in length. A word can be divided into number of bit fields. We can define the bit fields in structure and union in the below mentioned way. For example, I have taken an example of a structure. Struct student unsigned integer number colon 7. Whatever integer value we are specifying after the colon, that indicates that the total bits required to store the value for this particular member. So if I write unsigned integer number colon 7, it says that from the 16 bits it will use only 7 bits. Enrollment number will use only 7 bits of it. The rest of the 9 bits will not get used. So memory can be saved. Similarly, character name 20, character address 50, unsigned integer age 7. As I told you earlier, over here we are considering the maximum age as 100, and to store the maximum value 100 in a variable we require only 7 bits. So instead of occupying 16 bits to age and enrollment number, at a compilation time, our structure, or you can say our compiler, will assign only 7 bits to enrollment number and age. By this way, we can save 18 bits together in this two member declaration, right? The intention of writing unsigned keyword prior to integer is that in a binary number system, the most significant bits, MSB bits, or you can say the bit available in the leftmost side, indicates the sign of a particular value. So if we are not writing unsigned keyword in the beginning of integer, then the first bit of value will be considered as the sign of a particular value. So while displaying the output, such kind of mistake may result an erroneous output. That is why I have taken unsigned integer for enrollment number and age, because the enrollment number and age cannot be a negative value. In above definition, ER number and age uses separate memory space of 7 bits each instead of 16 bits each. We cannot use scanf. This is the most important point, that we cannot use scanf to read values into a bit field. Instead of that, we can assign a constant to a bit field variable, or else we can scan the value in a temporary variable, and then after we can assign the the value stored in temporary variable into a corresponding bit field variable. One more thing we need to remember over here, pointers cannot be used to access bit field variable. Selection operators in structure and union. Till now we have seen how we can define structure and union, how we can declare structure and union variables. Now it is time to access the members of structure and union. C supports two different types of selection operators, that is direct member selector dot and indirect or pointer member selector arrow operator. To access elements in a structure using a structure variable, we use a record selector dot. For example, if I would like to assign a value to my name member of structure student in st1 variable, then I can write strcpy st1, which is a structure variable, dot name, which is a member of structure, equals to whatever value you want to store in it. Suppose that the object S is of struct type student and sptr is a pointer to student, then if M is a member identifier declared in structure, these two expressions like s.name and sptr arrow name represent the member object name in student data structure. Over here you need to remember that s is a simple structure variable, where sptr is a pointer of structure student, right? So over here you just need to remember the only one thing. If you are using pointer for a structure, then you can access the member of that structure using the pointer with the help of arrow operator. The expression sptr arrow age is convenient synonym for pointer sptr dot age. That's it for today's lecture. I hope you have understood the concept of structure and union. Thank you. Thanks for watching my lecture.